in two or more resources that we have, we use the rule that is commonly called Johnson rule. Let's learn about that in this video.
Let's take a look at the famous model of the sequencing. Let's take a look at this famous model to sequence the job to the resources that is more than one, that is called the Johnson rule. Before that, let's discuss about the critical ratio. Critical ratio is an index, is simply an index number that is gathered from dividing the time remaining, so the time remaining until the due date, and by the work time remaining on the job. So we just simply compare the time we have and the time required to complete the job. The job with the critical ratio are scheduled ahead of job with higher critical ratio. So this critical ratio we can use to make a priority, to dynamically make a priority of the job that currently in the working in process. This critical ratio is performed well on the average of job lateness criteria. So this one, the critical ratio formula is due date minus today's date divided by the time remaining. Take a look at this simple example. Currently is day 25. We have three jobs in here. Job A, B, C with the due date A 30, due date B is 28, and due date C is 27. And work days remaining for completing this job is A is 4, B is 5, and C is 2. And then from the critical ratio, we can calculate the critical ratio based on this situation. So due date 30, the due date minus current date is in here, divided by the work days remaining 4, so equal to 1.25. So we can do the same with the job B in this case, with result at 0.6 critical ratio and the 1 critical ratio for job C in this case. So how we can make the priority? So we should make the priority for the job that having a low critical ratio. So in this case, so this is priority order number 1, this is priority order number 2, and priority order number 3. So here the critical ratio less than 1, it means that the job is late. Critical ratio 1 is just exactly on schedule, and critical ratio more than 1, so this is CR equal to 1, and critical ratio more than 1, it means they have some allowance time or slack time. Critical ratio technique help to determine the dynamic status of the specific job, and we can use the CR to establish relative priority among jobs on the common basis, similar basis, same basis among jobs. The third one, we can relate stock and make to order jobs on a common basis based on the critical ratio as well. And we can adjust the priority automatically for changes in both demand and job progress. So when there is a job progress is changing, we can adjust the sequence based on this critical ratio technique. And this is the best one. So dynamically track the job progress using the critical ratio. How we can sequence? Now we move on to the sequencing job on two machines using the rule. The famous rule is Johnson rule. This Johnson rule is work with two or more jobs that pass through the same two machines. So this is assignment of multiple jobs to two machine or work center. The purpose is to minimize the production time and idle time. Take a look at the algorithm in the Johnson rule. First, we list up all the job and time for each work center. The second, we choose the job with the shortest activity time. If the time is in the first work center, schedule the job first. If the job is in the second work center, schedule the job last. And the third one, when the job is scheduled, it is eliminated from the list. We should eliminate the job that already scheduled or assigned that. And then we should repeat the step number 2 and 3, working toward the center of the sequence. How we can do that? Let's take a look at the simple example. Based on the algorithm in Johnson rule, we should take a look at the minimum time for each job. So let's see in here, job A, this is have the minimum 2 in work center 2, so we should subsequence the job A less. So we put it A in here in the right hand side. And then let's take a look at B. So the minimum time is 3 between work center 1 and work center 2 is 3. So we should assign job B is first. Now take a look at job C. Job C, the minimum is here. So we should assign job C last. Job D is the minimum is in the work center 2. So job D will be here last again. And job E has the minimum in the minimum time in the work center 1, so job E should be here. So this is the sequence of the work, B, E, D, C, and followed by A. If we draw this into the Gantt chart, we will have the sequence like this. So in work center 1, so the job should be passing through work center 1 and then continue to work center 2. So like this, B, E, D, C, and A from work center 1, and take a look how we can put it into the Gantt chart for the work center 2. In the work center 2, we should wait. This is actually the idle time. So this is idle time, work center 2, and then the work center 2 can start working starting from time 3 in here, and then finish at 8, and then idle again, waiting job E from work center 1 finish, and then starting 10, then we can proceed the job E and finish at time 22. And then how about job D? Job D directly can enter work center 2 and finish at 29. C finish at 33, and job A finish at 35. And this is the until the 36, this is the idle time. So we can see that the work center 1 having the idle time in here, and work center 2 having idle time in multiple places. That is all about the Johnson rule and the critical ratio. I hope it gives you a clear explanation about how we can assign the multiple job to 2 work center and how we can dynamically make a priority during the job is processed in the work center. See you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.